Hi friends, welcome to episode 7 of Beginner's Answers for Heat Transfer. In this video, we'll be discussing about the different meshing options available in Apdl. In the previous video, we discussed how to set up a thermal analysis, how to model a structure. So let's start. So once we finish creating the model, the next option that we have to do is meshing. So go to meshing. The first tab in there is mesh attributes. Mesh attributes is used to basically assign different attributes to the part that we are going to mesh. So say it's a complex structure and there is 10 volumes, we can assign 10 different attributes to each one of the volume. The attributes that we can assign are the material number, the type of element that we use, etc. So first we go into mesh attributes, default attributes. Let's just keep it in the default values for now. Click OK. Here also we can select specific key points or lines or volumes and assign different materials for each of them. So let's go to mesh tool. So when we click on mesh tools, this window will open over here, which basically has all the options available in the meshing toolbar. It's basically a miniaturized version of the whole toolbar over here. So here at the top we can set the element attribute, what we are going to do our meshing on. So let's just keep into global. Then there is smart size. So in order to understand that concept, there is two type of meshing: free meshing and mapped meshing. In the case of free meshing, the Apdl software automatically detects the best possible meshing available for the structure. In the mapped meshing, we are deciding how to mesh. So in case we need a more accurate answer, mapped meshing is done. But for simple cases like this, even mapped meshing and the free meshing will be same. So this smart size option is for free meshing. We will be doing that. Here we have the size controls. Basically it's a mapped meshing system. So in that size control, we can control the number to which an structure can be meshed into. In the bottom here, we can select what we are going to mesh. So we can mesh volumes, areas, lines, and key points. Here we are selecting between tetragonal or hexagonal. So once we mesh the structure, it will be divided into smaller parts, and we can select the shape in which that can be meshed into. So when we go here, if we select tetragonal, it is always free meshing, and if we select hexagonal, we can do the mapped meshing. So for our case, I'm going with hexagonal. I'm going to show you both the ways. One is free meshing as well as mapped meshing. So in this case, how to do a free meshing? So select tetragonal. You can give a smart size. So as we go down, the number of elements in the structure will be more. As we go up, it will be lesser. So as we go finer, the answer or the solution that we get will be more and more accurate, but it will increase the calculation time. So let's keep it into 5 at the moment. And then we are meshing volumes. Click on mesh, then the old, click on our volume, click OK. So it is go ahead and meshing. So see, it is meshed, and you can see it is not a good mesh, because for a simple structure like this, tetragonal is not a good option. So let's go back to mesh tool, deselect smart sizing. Even if we don't deselect smart sizing, the Apdl will show an error that the smart sizing shouldn't be turned on while doing mapped meshing, and it will automatically turn off. And then go select hexagonal, it will select mapped meshing, and we haven't done any size controls. Even if we don't do any size controls, Apdl automatically assigns an arbitrary value for all the size controls. Go to mesh. So the small volume was opened, and to select the volume, select the volume and click OK. And then it will ask, it's already meshed, so do you want to remesh them? So click yes and click OK. So now this side is divided into say 14 and this side say 12. Now how to do a mapped meshing? It's a simple process. Just go to mesh tool. Here set the number of divisions in a line to say 70 or 7. Go to lines, click on set, then it will ask which all lines that we want to apply the element sizing. So I am going to select these 4 lines and click OK. So there is we have to set the number of divisions, so I am setting it into 7. Click OK, but it's not changed. We have to remesh it. So go again to mesh tool. We have already set the size control now, and the hexagonal mapped meshing is set. Go to mesh, click on the volume, click OK, and it will ask if you want to remesh. Go ahead, click OK. See, now this side is divided into 7 and this one is the old one itself. So that's how we do the map meshing. Now say we made a meshing and we want to clear the whole meshing. We don't want meshing, we want to pre-mesh it. We can go again to mesh tool. There's a clear option. Click on clear, select the volume, select OK. So everything will be wiped out, but the volume that we created is still there. So let's go into plot, click on volumes. Waha, the volume that we created is still there. So let me go ahead and remesh it. Go to mesh tool, everything is set, click on mesh, click the volume, click OK. So the whole structure is meshed again. So let's go ahead and discuss about the differences between a key point and a node. So go ahead and plot the volumes, and say here the vertices of this volume is called a key point. So whenever we create a geometry, the endpoints of that geometry is always called the key point. So now let's go ahead and click on elements. So here we have extra points. So here there is 7 extra points in between. Here maybe like 12, I guess. So those points are called the nodes. So if the subdivided elements has the vertices, and those vertices are always called nodes. So it is better always to apply our loads, not usually in the case of thermal, but in all other cases like the static structural cases, it is better to apply the loads on the key points rather than the nodes. This is said because say you did meshing, you solved everything and took the results, and you were not satisfied with the results because of the meshing, and you want to go back and remesh it. And if the loading was applied on the nodes, when you remesh it, the nodes will be moved and the loading conditions will be completely changed. But if it is applied on the key points, it won't change even if you remesh it. So it is better to apply loads over key points rather than nodes. Now let us discuss about numbering. So in this case, if I turn on nodes, you will see all the nodes available. If I turn on key points, you can see all the key points. So we have 8 key points and a lot of nodes. So now let's discuss about numbering. So go to plot control, click on numbering and turn on the node numbering, and I click OK. So that's a mess over there. So let's go to plot the key points, go to numbering, turn on key points and click OK. So as you see here, we didn't define any numbers to any key points, but Apdl automatically assigned numbers to each and every key point. So this one is key point number 1, here it is number 2, the coordinate system is blocking it actually. So 3, 4, 5, 6, 7, 8. So it was arbitrarily chosen and applied. So in every case, if you go into elements and go to numbering, turn on numbering for elements and turn it on and click OK. See, it is divided into different colorful elements and each element is given a different number. So if you go into numbering and select turn on area number, and for now we just deselect the node numbers and click OK and plot areas. So here see A1, A2, it is divided into different areas on all the sides. So this one is the first area, this one is the second area, so it is arbitrarily chosen. The next thing that we are going to discuss is the checking controls. It's basically like we are checking the integrity of the mesh or the quality of the mesh that we just created. So in that, I am just arbitrarily choosing shape checking. So the mesh tool wasn't closed, so let's close that. Go to summary and click OK. So here it shows the error percentage or warning percentage that can occur due to our meshing. So say if the meshing was on a complex structure and there is more warnings or errors related to the meshing, that will show more discrepancies related to the final answer. So try maximum to reduce the number of errors. That is usually through mapped meshing. Let's go ahead and close this. The next thing we are discussing is about loading. In the loading case, we are discussing the different loads that we are applying onto the structure. So in our thermal analysis, is the temperatures are the loads. So in here, go to analysis type, click on new analysis. So there is steady state, transient and substructuring. Today we are going to do the steady state case. So let's click on OK, then go to define loads. So now we are going to apply the temperatures. So let's go to apply. We are doing thermal, so go to thermal and we are going to apply temperatures. Click on temperatures. Now where we want to apply it, we want to apply on the both sides of the window. So on areas, click on areas. So now it asks us to select which area to apply the temperature to. So I am selecting this area, click on OK. So this screen will open, which allows us to add the temperature. So here I am selecting temperature and it has constant value throughout, and click here and the temperature was 289.15. it's set to Kelvin, so go ahead, click OK. So in that side temperature is set to 289.15 Kelvin. So let's go ahead and set the temperature on the other side of the window. So let's go into dynamic model mode, rotate the structure a little bit so that we can select easily, and then go again to apply thermal temperature areas. Click on this area. No, that's the wrong area. That is also the wrong area. This area. So make sure you select the right area, and as I told, just click on the right button of the mouse to switch between pick and unpick, and click on OK. And the temperature here is to 79.15 and click OK. So now the thermal loads are applied. Let me switch back to isometric view and get a fit view. So now the temperature is set, and all the loading conditions, the meshing, everything is over. So that is basically the pre-processing stage. So almost the important parts in the pre-processor stage was discussed here. Now we are going to solve the model. Solving is basically the easiest thing that we can do in Apdl. Just go to solutions, click on solve. There are other options also here, like the analysis type that we did in the preprocessor itself, also the defining load case that was also there in the preprocessor. So go to solve, current load step. So it will have a small summary about what all we did. So it is static state, steady state, a 3D geometry is there, and we are only using one step and 1 second or 1 unit. Actually it is set into 1 unit of time, and number of substeps is 1, and click OK, and it is solving as we speak. So solution is done. Now click close. So the solution was done for the structure, and let's go to the general post processes in the next video. Thank you.